Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class, we are going to discuss the topic moment of inertia of a circular section. Moment of inertia of the circular section with respect to ZZ axis passes through the center of gravity. Here ZZ axis means the axis which is perpendicular to the plane of the screen or plane of the paper. Here we can say plane of the screen. Okay, to the screen, the ZZ axis is perpendicular axis. Okay, then the XX and YY. For these two axes also, we are going to calculate the moment of inertia of the circular section. XX and YY, these are all the horizontal and vertical axis passes through the center of gravity of the circular section, and these two axes are lying on the plane of the circular section, but the ZZ axis is perpendicular to the plane of this circular section. Okay, and here R is the radius. Okay, R is the radius of the circular section. R is the radius of the circular section. Here, first consider, that means this entire thing is a circular lamina. First here, we are going to consider an elementary ring. Okay, this one. Consider an elemental ring for differentiation purpose. The radius of the ring, that is x. Okay, this one is the radius, and the thickness of the ring, that means this dimension, that we are going to take as dx, that is thickness of the ring, considered ring, that is dx. Then we know that the area of the ring, area of the considered ring, dA, that we can write 2 pi x, that means 2 pi multiplied with the radius multiplied with the thickness. So it is 2 pi x dx. Okay, this is dA. Then we know that the moment of inertia with respect to the ZZ axis, which passes through the center of gravity perpendicular to the plane of the circular lamina. Okay, that means only for the ring. Okay, this is moment of inertia of the ring. Okay, the IZZ, that is moment of inertia of the ring with respect to ZZ axis. We know that this is the area, so that will be for the ring. Okay, this is for the ring, that we can write as dA multiplied with the radius or this distance, that is x square. And we know the value of dA, that is 2 by x dx. So 2 pi x dx multiplied with x square. So we can write 2 by x multiplied with this x. So it will be 2 pi x cube dx. Okay, here this one, 2 pi x dx, that is dA multiplied with x square. Okay, so here, so it will be 2 pi x and this one x. So 2 pi x cube dx, that is di, or the moment of inertia of the ring with respect to the zz axis. Now, moment of inertia of the whole circular section with respect to zz axis. For that is izz. We have to integrate this with respect to 0 to the limits radius. Okay, so integral of 2 pi x cube dx 0 to the radius. Here 2 pi is a constant that we can take outside. Integral of x cube dx 0 to r. We know the formula of the integral. Integral of x power n dx. We will get, that means integral of x power n dx. That is x power n plus 1 divided by n plus 1. So here n is 3. We will get x power 4 divided by 4. So 2 pi, this one, x power 4 by 4, then limit 0 to r. Then we can write 2 pi r power 4 by 4. Then we can cancel this. So we will get pi by 2 r power 4. Okay. Then we know that r equal to d by 2. If we substitute, then I set that will be pi by 32 d power 4. And then we know that as per the perpendicular axis theorem, Ixx, Iyy, that is Izz divided by 2. So if this is Izz, then we can write Ixx or Iyy. That will be this value divided by 2. That means we will get pi by 64 d power 4. Okay. So now we got the values for moment of inertia with respect to the zz axis, which passes through the center of gravity. Here zz axis means the perpendicular axis, or the axis perpendicular to the plane of the circular section. XXYY, that is the horizontal and vertical axis, passes through the center of gravity, and both the axes lie with the plane of the circular section. Okay, that moment of inertia values we derived. Then these values we are going to interpret for the hollow circular section. Hollow circular section with the outer dia capital D and then the inner diameter small d. So here D, that is the outer dia, and small d, that is the inner diameter. Then for this value I set, we can take pi by 32 first for the outer dia, capital D power 4 minus small d power 4. Same way, as per the perpendicular axis theorem, okay, Ixx, which is equal to Iyy, that equal to I set by 2. So this will be pi by 64 capital D power 4 minus small d power 4. Okay. So now we derived the equations for the moment of inertia of a circular and also interpret the values into the hollow circular section. I hope you all understand this derivation. For more videos on the topic, moment of inertia, Don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Thank you guys. Thanks for watching.